I've recently become fascinated with Oscar Sala's Mixtur Trautonium, and I thought I'd try to model it in the EaganMatrix, or at least some semblance of it. I'm not going to really get an exact model here. But let's begin this, because before you use this preset, if you want to, you're going to have to know some things about how it works, and even a little bit of EaganMatrix tweaking to get the most out of it. Let's bring up this interesting Doepfer, which is the major manufacturer, at least the original, of Eurorack modular synthesizers modules, though you can get many different companies' modules these days. But Doepfer has an interesting project that they created modules to try and model the Mixtur Trautonium, and let's just review. Obviously, it has a manual here, which is kind of interesting, with a ribbon-like device that's connected to these tongues that you press down. You can get a continuous pitch as well as discrete pitches with these tongues. So obviously, we're going to forget about that. Our fingerboard is going to do this job for us here. So everything in relationship to this instrument that would be used using the manual, we're going to use the fingerboard. Also, there's a envelope ADSR component to this instrument as well, and once again, we're going to be the envelope generator as usual with the fingerboard. So what we really want to do now is look at what are the main constructs of this wonderful instrument. Doepfer, by the way, also has this ribbon controller you can buy to connect up to their modules, but again, we don't really care about that. The basics of this thing revolve around two things. Number one, the subharmonic generator, which allows you to create up to basically four oscillators that can be set to subharmonics. So instead of harmonic frequencies going up the harmonic series, this is going to go down the harmonic series, and it can create some amazingly low tones, obviously, depending upon how you're setting it here, because you're setting subharmonics, or sometimes they use the term undertone instead of normal harmonics. Though with the preset that I've created here, you can very easily go the other direction with a little tweaking if you want to. So there's this subharmonic generator, which lets you set the divisor of these subharmonics. That also lets you set presets that you can recall. We can do that in the EaganMatrix by simply setting up a number of presets in our 16 recall memory up here. And that's how we're going to deal with the preset issue, because it'll take a little too much tweaking to do this in real time if you want to go from sound to sound. Now, in addition to the subharmonic tone generator, the second major function of the Mixtur Trautonium is the formant filter, and this allows basically four filters to be run in parallel, and you can set the input level and then frequency and resonance and level of each of these filters. This is going to create somewhat of a problem for us in the EaganMatrix, as you'll see, because there's not enough resources to have both four filters and four oscillators going at the same time, in addition to all the other stuff that we want to add. So let's just take a look at what Doepfer prescribes as the block diagram for this thing basically has a master oscillator that is going to control these subharmonic oscillators. Well, our master oscillator, we're just going to use the X function as the base frequency that we're going to feed into some oscillators and set the subharmonics of, as you'll see in a second. There's also a side oscillator, a separate oscillator that's used to create effects, and we'll add a side oscillator in our preset as well. And it has a noise generator, which, when run through these filters, can create some very interesting sound effects as well. So we're going to have to figure out a way to get noise into this preset as well. Now those get sent through basically 12 dB formant filters that can be set to either band pass or low pass, and then that gets mixed out to a voltage controlled amplifier and goes to your speakers eventually. And then there's this other the set of functions, the Schlagwerk, which basically is an envelope generator and an LFO. Well, we can simulate some of these LFO functions through shape generators, and also just maybe if we wanted to, some of the ADSR functions, but we're not going to worry about that. As we said, we'll use the fingerboard and our finger articulations to deal with ADSR. So you can see from this diagram, most all these things are available in the EaganMatrix, the wonderful EaganMatrix. And so let's take a look at what I did here. I'm not trying to actually model this thing 100%. I'm just trying to get the basic flavor of a Trautonium or Mixtur Trautonium going here. So what I did is I created a master side oscillator here on oscillator 1, and you'll see, and I can set the frequency of this and independently at least frequency offset of this independently from the other oscillators going. Now I had two choices. Either I could try and create 4 oscillators and feed them into a filter, which I actually did over here. My first attempt was to take 4 oscillators and feed them into a big bank filter. And that creates some nice sounds that I can get out of there. But the problem I had here was I couldn't vary the sound enough this way, and it just so happens that the EaganMatrix gives me a bank of oscillators that I can use. Now when I use a bank of oscillators, I don't have quite as much control over each one of them as I do here, but if I use a bank of oscillators, a wave bank, I can feed that into 4 separate filters. And because of all the filter choices that I have in the EaganMatrix, I can actually create something that's even more powerful in some ways than the filters that's used in the Trautonium. And I thought I didn't want to limit myself just to the 2 kinds of filters here when Ed gives us all these other filter types. So basically that's what I do. Now for the subharmonics, I basically created 4 barrels, and each one of those barrels is set up so that it has a multiplier on it when it's set for one of the 4 frequencies that I've used in the wave bank. And then to basically feed that the A bank over here, you can see I feed that with 4 different formulas into my filters. Why 4 different formulas here? Just so that I can change the amplitude of each one of these waves going, each of the wave banks. I can change the amplitude going into each of these filters. If I just had them all going in at the same amplitude, that's not as flexible as my being able to set and control the amount of Z going into each one. And when you use this, you can actually do that if you want. You can go in, and if you feel like one of the filters wants to be increased a little bit in amplitude, you can go in and change your amplitudes down here. That's one of the things you can do. Okay, so I basically fed the oscillators into the filters, and that takes care of basically the 2 main components of the Mixtur Trautonium, my subharmonic based oscillators, which I used 4 of the waves that I can set in the wave bank here. One of the other things I can do that the Trautonium didn't, the Trautonium actually uses a sawtooth waveform, but the wave bank gives me the opportunity to switch that off between saw, square, and triangle, so I can even create even greater harmonic flexibility this way. Again, I'm not trying to model the Trautonium exactly. I'm just trying to create something in the EaganMatrix that'll give me this wonderful flexibility of this Frankenstein-like instrument that can sound like so many things. All right. What do we do about the side oscillator? As I said, I've created a separate oscillator that I can control with this side oscillator offset. And what this offset will do is simply take the frequency of the oscillator, which I basically set by default to the first, whatever the first wave is going on in my subharmonic series here. I set the side oscillator to that frequency, but I can offset that frequency with this dial, and that can create some really interesting fractional harmonic differences depending on how I set that, which I think is in the realm of what the original instrument intended that for, at least one of the things. Now noise, what I did with that was I'm running out of resources here, controls. So for noise, what I did was carve up the fingerboard in such a way that I'm feeding the noise into a BIC bank. And as you can see here, the Y formula of that noise is set such that the first 2/3 of the fingerboard is really going to play my bass sound, and when I get to that second, the top third, that's where I'm going to kick out the bass sound, and I'm going to bring in the noise. All right. And one of the great things we can do with this BIC bank is, depending upon how you set the bandwidth of that, and this bandwidth control, again, unfortunately, I ran out of control, so the bandwidth knob both controls the bandwidth of each of the filters as well as the bandwidth of the BIC bank itself. But because that BIC bank is played on the top half of Y, if you're not going back and forth, you can set that bandwidth whatever you want. But that's one of the issues I had here in trying to take the resources and make them as optimal as I can. So one of the great things about this BIC bank is, depending upon how you set that bandwidth, you can have this thing sound like a string being plucked, not just noise. I can set it to sound like white noise, but if I just finally tweak the bandwidth of this thing, I can get some very interesting sounds coming out. And you can see this is one of the sounds that many of the other presets try and use. And so that's just about all we need to start using this thing. The only other thing is the Trautonium also had this concept of using a a frequency shifter. Now, frequency shifter is not just a pitch shifter that raises all of the pitches and its harmonics by some fixed amount, so you basically maintain the harmonic structure of your sound. A pitch shifter will shift the harmonics as well as the bass frequency itself, and what that tends to do is to give you these fractional harmonic combinations where you get kind of clanging sounds. A pitch shifter is kind of like a ring modulator that only basically uses the difference or the sum. So how do I model that? I can't model an actual pitch shifter per se here easily, but what I did was I basically used some offsets on all these pitches that I created that only get triggered when I use the touche area. And so what I can do there is also set some shape generators that come in on that as well. to create some interesting sounds and maybe bird-like sounds. I think that the Trautonium was used to create the bird sounds in the movie The Birds. And if we go down here, I can get something very similar to that out by applying these multiple shape generators to these frequencies at different multiples that you can change yourself. You can change these multiples on the shape generators to get a little different kind of sound coming out. For example, here I changed them to be much faster. Also on the touche area, I have a Y component there that raises the frequency as you raise Y. So you can see I can do a lot of things here. So let's get to some of the basic sounds. Now, I set it up so that the basic thing coming out uses a triangle wave, which isn't really what the original instrument used the sawtooth. But this triangle wave gives me a more siny-like sound, and with some side oscillator kicked in here, it has a sound. You can get a sound out of it. That's kind of like that nice sound that the Trautonium can create. And if I play just one note, you can hear all the different harmonics in there. And what I have this one set to is the first harmonic, which would be your fundamental, then the second harmonic, which would be an octave below, and then it goes through the harmonic series, you know, by 1/3, 1/4, and you can go up to 1/12. Ed has this nice control here that goes 1 to 12. So instead of going up to, I think the original went up to 24 subharmonics, but 12 should be plenty here. Another thing is, because you know, some of these subharmonics can get pretty low, I also put a pedal on so that you can raise things up an octave, which a lot of times you'll want to do to let those, if you have a lot of high subharmonics in there, or really low tones is what it maps to, you might want to have an octave pedal there, especially with a half unit like I have. All right, so now I think you get the idea. Some of the things you can do here now, as Oscar, when you see him playing this instrument, he'd be twiddling knobs and rotating his pitch shifter and doing all kinds of stuff. So when you play this preset, you're probably going to want to do something similar. I have it connected up to my Kenton Kilomix here so that I can change the subharmonics easily. Now, obviously, if I change, oops, I don't want to change the mix there. So let's bring that back a bit. And you can hear now, if I start with the first one, as I raise the value, I'm getting lower harmonics. If you start too low, they'll be so low you can't hear them. So, but as you play around with this thing, you can set these things and also change your waveform to get much different sounds. So there's the triangle sound, and it's also, I used the high pass filters on this one that weren't even on the original. And we have that plucking kind of sound. Here's another one where I basically changed it to a sawtooth bank now, and changed the subharmonic structure. I also changed the bandwidth. I made it higher, so it's going to be more of a blowing now instead of that plucking. And obviously with the sawtooth, you get that much more, you know, buzzing, nice sound. Now, if I'd taken this and just applied, say, low-pass filters instead of those high ones, and I'm basically setting my my cutoff um, at, at the subharmonic frequency. You can play around with that if you wanted to, but so there, when using the low pass filter, obviously it takes a lot of that high harmonic content out, and you can play around with that. Um, you can also set things up so that, let's see, if I wanted to, uh, let's play around with the side oscillator. So there's a much more saw-like sound. I've sent things through a low-pass filter. I've also set the side oscillator up here um, to sound a little more sawtooth-like, to be in kind of in tune with what's going on here. So now let's bring up the side oscillator. So you can see how you can play with that. Now another thing you can do with the side oscillator is it's set to have its offset to be rather high in terms of the frequency content. If I want to set that, say, lower, now as I turn the dial I'm going to change frequency much less, and what you can do, you can set that frequency up so that it's close to the base frequency and get yourself some little bit of, you know, modulation going on there, and get a little you know, a little bit of vibrato implied in the sound itself that you won't hear that much when you're implying your own, but it gives it a little bit of a and there I've applied it, plucking with going through, and I've changed the frequency spread from what I had originally just a little bit. You can go through here and tweak these things a bit in the Big Bank, and now it's kind of like a kind of halfway between a pluck and a blow. So there you have it. I think that kind of explains what I've done here. If you want to try this out, I kind of think it's fun to play, and you can get some really nice tones out of it in and of itself. One last thing is, look, what happens if you just set them all to the base frequency? I mean, then everything's playing the same. So you can play around, and really interesting instrument, the Mixtur Trautonium. And while I haven't done it exactly, I think there's enough similarity here to give you at least a taste of what this instrument is. And I probably should tweak it a bit more. Another thing you can do, by the way, is these controls for the convolution. You can set these to different values too, and that'll change the sound slightly as well. So many different things you can change in the EaganMatrix to slightly get different sounds coming out. It's just amazing. Okay, I think that pretty much wraps this up. Hope you like the preset.